Assalamu alaikum warahmatullahi wabarakatuh. How are you guys? Miss you too much. Our today's lesson about chapter 8 applications of definite integrals. Especially we're going to learn the how to determine the volumes in another way instead of the basic rules for any solid. So today's lesson is to determine the volume by using integration. First of all, some formulas of area, like the area of the square with side x squared. The area of the semicircle of radius x is pi x squared over 2. The semicircle with diameter x is pi x squared over 8. An equilateral triangle with side length x is radical 3 over 4x squared. An isosceles triangle with two sides 2x and length side x is radical 15x squared over 4. And now let's see something about how to determine the volume. Why we're going to learn that? We're going to learn that for determine the volume in a certain solid in 3D, and how we're going to use first square cross section or circular cross section, all cylindrical shells. That's our today's lecture about square cross section, circular cross sections, cylindrical shells. First of all, how to determine the volume using cross section. Please don't be worried. We have to integrate from the first initial point of x to the terminal point of x for the function or the area into dx. It's too easy. Too easy. First, how to determine the volume. Sketch the cross section. Find the formula of the function, which is the area. Find the limits of integration, integrate, and define the volume. I'll give you the sketch, okay? I'll give you the sketch already. It's okay. This pyramid with 3 meters high has congruent triangle sides and a square base that is 3 meters on each side. Each cross section of the pyramid parallel to the square. Just find the cross section here. This cross section in the form of square. Any cross section in this pyramid in the form of square with side x. Our volume is determined after integrate the area of this cross section, which is x squared, into dx from a to b or from 0 to 3. That's all. Here we already found the formula, which is x squared, and we can just find the integration of x squared dx from 0 to 3. After integrate it and replace x by 3, the resultant will be 9. The first part already we have finished, how to use cross sections to determine the volume. The second part, the solid of revolution. While viewing the word revolution, just find the integration of pi f of x squared dx for the word revolution from a to b. Here we have a function called 2 plus x cosine x, and the interval is -2 to 2 and revolved about the x-axis. Find the volume. That's our keywords. Just please determine the integration from -2 to 2 pi fx squared f of x squared dx. Again, it's integrate from -2 to 2 as we said, pi into the function x plus x cosine squared dx. It's not x, it's here is 2. Just integrate 2 plus x cosine x squared. After that, replace x by 2 once and -2 1, then subtract at the boundary integration and determine the volume. The third part here is to find the volume using cylindrical shells. The region here is bounded by the curve y is radical x, the x-axis, and the line x equals 4 is revolved about x-axis. Revolution about x-axis here means we have to write x in terms of y instead of y in terms of x. Again, is to revolve about x-axis, you have to determine the rule x in terms of y. After squaring, and by squaring here, x becomes y squared. The line x equals 4 here means you have to move or translate it 4 units to the right. It becomes the line, it becomes the part 4 minus x squared. So it's x equals y squared and 4 units right, so it becomes 4 minus y squared. This part called the shell height. And we have a shell radius here, which is y. The rule is to multiply the shell height into the shell root into the thickness, which is dy. I'll give you the sketch, okay? Just you have to find the shell height, which is 4 minus y squared, because y squared is x, or x is y squared, and translated to the line x equals 4, then our rule becomes integrate the interval from 0 to 2 as we said here, from 0 to 2, here from 0 to 2, and here is the line x equals 4, which is parallel to y-axis. Here is the shell height, 4 minus y squared, the shell radius, y, and the thickness, which is dy. Just we can integrate. The rule becomes 2 pi into the shell radius into the shell height. The shell radius is y, the shell height is 4 minus y squared into dy. After integration and replace y by 2, the resultant will be 8 pi. We learned today something about how to determine the volume using integration by 3 ways: the cross section, the cylindrical shells, and the cross part. So we learned 3 individual exercises about this part. Thanks for listening and goodbye.